out for the test. So first, you ought to be using a pen instead of a pencil. The pencil is only the marker can use pencil. So that we don't override each other, and then when you erase something, you don't erase your stuff. Second thing is in question 1. Unfortunately, I can't show anything. So question 1, right? Ask you to write the declaration of some of the functions, but not the implementation. And a lot of people wrote implementation instead, and you don't get any mark down for that. But if the question asks you to write declaration and specifically not implementation, and you still write the implementation, that just shows that you don't understand the question. Second, in part C, I think, it asks you to write the mutator for age and name, but not gender. And a lot of people still provide the gender mutator. And you do get marked down for that. Another thing is, if you look at the example that is shown, when you construct a person with some invalid argument, they default to, I think, female and age 0, right? So that means that inside the constructor you need to do some checking as well. If you provide gender being something other than M and F, then you need to default to F. If age is less than 0, then it needs to default to 0. Also, the constructor that is both default and user defined is a constructor with all arguments having the default value. So with an argument, with the constructor like this, name, string, name is 0, but is nothing. Int age is 0, and gender, string gender is nothing. With this constructor, you can call person with nothing, with no argument. This is calling the default constructor, right? You can also call a constructor with any of these arguments, and it will still work. So that's the meaning of a constructor, which is both default and user defined. And the default value should be defined in the declaration here. So you don't omit these default values, and then when you implement it down here, you start providing the default value. So the default value should be defined where the declaration is. Yeah, other than that, everything else is quite mechanical. And the answer for question 2 is yes, no, no, yes, yes, no. Answer for question 3 is 2, 4, 1, 2, 5, 8. And you get 1 mark for every correct answer. So there are 6 of course. A lot of people struggle with writing the operator output and input. So I think the trick to remember this is the first and the return value always have the same type. So for operator output, the first argument is outstream, and the return value is also outstream. And because you have a return value, you need to return something. and the almost exact same thing happens to the operator input. In this case, it's in stream, in stream, in, return. The second argument is always the class that you're implementing. The second argument here, remove these. Something, and the second argument is always person, or whatever class you're implementing. You can make the const here. So it's easy to remember if you understand the structure, what actually happens inside a function. So when you call cout in person P, right, what happens is the cout is an existing instance of the outstream class. It's going to be plugged in. Even though you call cout before P, what happens is the actual function is going to be called P dot operator output, and then this goes in as a first argument. So that's why this is not a new instance, it is a reference to an existing instance. And because you can chain it, so like this, after you print out P, you can print out the inline character as well. You need to return this so that it can continue to do its job. So that's the structure of this function, and the same structure happens to this function as well. If you understand what happens, then it's not that difficult to remember how to write these functions. So, any question about your script? Any disputes? If not, we will go into today's lecture. So today we will learn about abstract classes. So last week we learned about virtual functions. So abstract classes, class with every function being virtual function, and all the functions are pure virtual. Right? So what does it mean to be pure virtual? So if you have a base class with some function foo, some sort of type, some sort of argument, and then you derive B, and then you override this, and this one is virtual. Void. You override it. What happens is you end up with two functions, one for B and one for D. And depending on what type of instance are created at runtime, one of these functions will be called. So when you have a D object, so we have B, we have D, and overriding as well. If we have a B object, then when you call B.foo, this function will be called. When you have a D object, and you call D.foo, this function will be called. And if you have a D object but you reference it as a B object, B0, for example, is D, and then you call D0.foo, then if this function is virtual, this one will be called. If it's not, then this one will be called. Okay? So we have two functions. Now, what it means to be pure virtual is that you only have declaration, you don't have implementation. Right? So if you declare this in B as non-pure, then you will have to provide the implementation of full somewhere down here. You can do something or you can do nothing, but if you must provide the implementation of full without this. But when you have a pure virtual, then you cannot provide this at all. So what happens when we derive D from D is that the compiler will say, okay, B has a full function which doesn't have an implementation. So I expect D to have an implementation, so that when you call full, I know which one to invoke. And when you implement full here, it is not overriding anything. It is actually implementing something that you haven't implemented. And because this full function doesn't exist, you have two full functions, but in this case, because this one is pure, this one doesn't really exist at all in memory. Only this one exists. So because this doesn't exist, there is no way you can call B a full. So you cannot instantiate a B class if it has a pure virtual function. It doesn't make sense to do this, because when you have an object of type B and you call B a full, the compiler will have no idea which one to call. This is B, is not D at all. So if you instantiate it as a B, then you can forget about it. And because there is no implementation full in B, the compiler don't know what to do, doesn't know what to do. So in C++, you cannot instantiate this is invalid. Now a class that cannot be instantiated is called an abstract class. So when we come to Java, abstract classes are denoted with a keyword abstract, like abstract class. And if you declare something to be abstract, it cannot be instantiated, even if that class has no pure virtual or has no function at all. But that is Java. I digress. All right. So do you understand why B cannot be instantiated? Because if you do, then what happens when you call a function that is pure? There is no implementation. So to prevent that scenario, the language prohibits you from instantiating an object of a class that is abstract. Yeah. Understand? Still confused? All right, so what's the difference between a virtual function and a pure virtual function? A pure virtual function is just the declaration. There is no implementation. If you declare something to be 0 and to be pure, you cannot provide a body for it. It's invalid. And then when you have a derived class and you implement full, this is not overriding. This is not overriding because there is nothing for it to override. This is simply to fulfill the requirement of being a derived class of B. All right. Let's see what do we have here. So wording, inheritance. Now, in terms of semantic, sometimes it makes sense to make something abstract for the sake of argument. Right? Where we have an animal. Animal can be anything. So when you say I have an animal in my house, what does that mean? Is it a cat or a dog or a baby? So in terms of language, it doesn't make sense to have an object that is an animal. An object has to be something more specific than animal. Yeah. So yeah, it makes sense to have these when you So when do you need to make a class abstract? Why do we need to do this? Why don't we just provide with an empty body, and then all the derived classes will implement that? So the reason is sometimes you intend this to have multiple implementation, and you don't know which one to be called when you write class B. For example, when we have an animal class, and we provide a function, all animals can move, right? But a dog moves in a different way to a bird, so we don't really know what will actually happen when we declare this. So there is no way that we can implement something because it doesn't make sense. We don't even know what animal it is. So it's better to delegate the job of implementing move to a more specific base class. When you have a class, implementing animal, then you can provide the actual action that happens inside it. This slide uses shape and circle. So this is about whether it makes sense semantically to have something, to have an instance of a base class. Not all classes can be thought of as a semantical object. So this is just an example to make it clearer. When you design your class, sometimes it could be very hard to decide whether you should make a class abstract. When you get into that problem, you ask yourself whether you intend your class to be inherited by more than one class, and whether you intend to have a function to have radically different operation happening. So let's say we don't have an animal class, but we have flyable, and we have bird class. And then we have let's say saddleback is a small bird, which is a derived class of bird. It's not bird, it's fly. And then we have bellbird, which is also a derived class of bird. And in this case, even though you have more than one derived class, it doesn't make sense for this fly function to be implemented into these derived classes because they're not different. In fact, they're the same. So these two birds still flap their wings and fly in the exact same way. So it doesn't make sense to make this a pure virtual. Even though you can say, I cannot have a bird, I must have either a saddleback or bellbird or more specific type. But in terms of functional, if you have two classes that implement the same function in the exact same way, then maybe that function shouldn't be abstract, shouldn't be pure in the base class. When you have something that you intend to be abstract, then it doesn't make sense to have an instance of an abstract class. Now this is different in other languages. In Python, at least, you can actually create an object, an instance of an abstract class, and then you will inject the function later. It's called dependency injection. But in C++, everything has to be complete by the time of compilation. So if you have an abstract class with a function that has not been implemented, then for completeness, it doesn't make sense to create an instance. out of that class. Alright, so let's do some small quiz. So this is kind of a real-world example, but you'll find that it's not always straightforward which one should be abstract and which one should not be abstract. Right. So imagine that you need to deliver some sort of partial. Deliver a partial. And your boss say, move this partial from point A to point B using some sort of transportation. So if we plug in the very top class, land transport, right? So if your boss say, please deliver this partial from point A to point B using land transport, what does that mean? You have no idea what it means. So that is very ambiguous, right? Because there are so many different ways to transport something on land. That is not clear enough, and the action involved in moving the partial from point A to point B is not defined in this class. Obviously, it should be abstract. All right, so let's move on and ask your boss, what do you mean land transport? He's probably say, I want you to move it on foot. Right. So does that mean walk or run? You can move an object from A to B either walking or running. But are they different? You don't need to be told whether you should walk or run. Right? If someone tells you to move something on foot, you know what to do. You can run or walk or a combination of both. So these two classes, even though they are kind of different, somewhat different, it doesn't make sense to say they are radically different, and therefore on foot should be an abstract class. So when your boss says, move something from point A to point B on foot, that is clear enough, and you don't need to ask more questions. So this one should not be abstract. How about animal powers? Your boss says, move a partial from Auckland to Wellington using animal-powered transportation. What does that mean? So is that clear enough? Don't think so. So you ask more, your boss a little bit more specific what you mean by animal power, because there are two modes of transportation involving animals. You can ride on the back of the animal, or you can attach an animal to some sort of carriage. And then your boss will say, okay, because this object is not fragile, and you need to deliver it as quickly as possible, so use some sort of, ride on some sort of animal. So at this point, you can decide which animal to ride, because the action of riding an animal is the same whether or not the animal is a horse or an elephant. Conditions, this should not be an abstract class, because the action involved in moving an object using a horse and an elephant is the same. And the same here. Okay. I think I got the answer for the rest. Right, an abstract class doesn't have to have every function being pure. It can have data member as well. In x, y, you can have an actual function with the body. The only thing that it needs to be an abstract class is one function to be declared pure. This is all it needs. If you get a question, can an abstract class have data member? Yes, it can. Can an abstract class have a function that has an inline implementation? Yes, it can. Like this. So this is a syntax. So as you see, this constructor is not pure. In fact, constructor cannot be pure, as it cannot be virtual. But an abstract class can have private function, private members, public members, and everything else. So in here, when you have a shape, you know what an area is, but you don't really know how to calculate it until you know what specifically what shape it is. If I give you a shape and I ask you to calculate the area of it, before looking at the actual object I give you, you really have no idea, right? So it makes sense here to declare this one pure virtual, so that you can delegate the implementation of area to derived classes like circle or rectangle or triangle. Right, so the trick to when you design something and you don't know whether you should make a class abstract or not abstract, and whether you should make a function pure virtual or not pure virtual, try to think of at least two examples of possible derived classes, and think of how those derived classes implement the function in question. If you think they are radically different, then the original declaration should be pure. Alright, so the term for a non-abstract class is a concrete class. Some languages have special syntax, like Java. You will declare an abstract class with the keyword abstract. In Python, you will declare it with a meta class. I digress. Now, even though an abstract class cannot be instantiated, you can still use that class as a type of pointer. So you can say, I have an animal. Which is a cat, right? Now this translates to C++ like this. Animal. Cat. It totally makes sense to say things like this. Therefore, it totally makes sense to hold an object by the type of an abstract class. However, remember that when you call any function on this, the actual function will come from class cat instead, if it is pure and virtual. The keyword override. Why are we having this here? This is not necessary. This is not mandatory. When you override something, if you declare it to be override, then the compiler will check for you whether it is actually overriding anything. Because you might end up with a very, very long function with 10 different arguments, full with argument 1 being string, and then int, and then double, and then so on and so forth. And it's quite hard to keep track of the declaration of this, especially when you change. You would declare the function you override with this keyword. Right? So if you mess up something, instead of in and double, and when you implement it, you implement it with a double and then in. Then the compiler will tell you. But if you don't have that, then because the compiler will automatically convert int double and double to int, you may have problem in the future if you don't have that check in mind in place. So this is just a check. When you do your assignment, you probably don't have to, but it's good practice to still do so. the opposite of an abstract class is a final class. And the opposite of a pure virtual function is a final function. So final means that you cannot override it, or you cannot inherit it. If you intend your class to be, if you write a library for your customers, and you don't want your customer to override something, then you would declare final. So you're writing a banking library, and then you have a function, let's say, confirm identity. Now, if this is not final, then your customer can override this and change its behavior. Instead of checking for identity, it can actually do something malicious. So you don't want this to be there for people to override at will. You would say it's final. And it must happen this way. You must compare an idea of this person with an idea of this transaction. And the way to declare something final is to put the keyword final at the end. So in here, we can put a keyword final here, plus a final, and then this implementation will be invalid. And when you override something and you make that final, then you put the final keyword before the column. Same for function. This is quite self-explanatory. You cannot have a final and pure. Those are two opposite ideas. So you cannot say full final equals 0. You see that in your exam, then you know that's wrong. Now, a lot of languages allow you to inherit from multiple base classes. In this case, we have a tutor class. A tutor is both student and a staff. So any function you can call on student, you can call it on the tutor, and any function that you can call on staff, you can call it on the tutor. So it makes sense to have this tutor inherit both of these, but you don't have to redeclare an existing function with an existing behavior. However, in C++ there is no clear precedence of which one should be prioritized. Let's say in staff and student you implement the same function with the same signature. In staff you have function go to uni, and in student you also have the same function go to uni. When you have an instance of type staff, and you call staff.goToUni, that's understood. When you call the same function on student, that's understood. But when it comes to tutor, right, you call tutor.goToSchool, right? So what does that mean? Are you calling me as go to school as a staff? Because staff has to park in a different car park, and student has to park in a different car park. Right? So it's ambiguous. In C++, there is no precedence. In Python, at least you can do that, but the first class will always be given precedence. So let's say in Python, this is a little bit off topic, but so that you understand. In Python, you can do class A, B, C, right? So B is the first base class, C is the second base class. And if there is any conflict between this, B will be given precedence. So if I implement tutor to be a derived class of both staff and student, when I call tutor.goToSchool, right, this function will be called. The function in staff will be called. But in C++, there is no such thing. And if you do this and you have two functions with the same name in two classes, you might not be able to compile. So be careful. Yeah, if I could plug in my computer, I'll show you how it works, but I'll figure out later. Right, so at this point, you've been dealing with some sort of inheritance already. When you implement the operator output, for example, the first argument that goes in is our string, right? Our string, sorry. So let's say you do implement this. You can call cout, which will print out the string, or you can call fl, which will print out a file. So these are two different objects and they operate in different ways. But you can use the same interface to interact with both of them. So if you look at this diagram, the reason why we can plug in fout here, fout is of type f, out string. And this is a type os string. The reason why we can plug this in here is because OF string is a child of, OF string is the child of O string. Exam, you might or might not be asked about, given this function with this signature that accepts a certain high string, which of these calls are correct, which of these calls are valid, and then there will be a call that plugs in an O string, and that will be invalid. I've seen that in one exam, but not all. So this is a little bit convoluted, but you might still want to remember the relationships between these classes. Demonstrate the conflict between two base classes. Now, if you design your class if you design all classes, then this is obviously the wrong way to do it. If you have a common data member, then it should not be in either staff or student. It should be in something like person. And staff will be a derived class of person, and student will be a derived class of person. So there is no conflict when you inherit staff and student from tutor, because both of them refer to the same data member. But sometimes in real life it's not so obvious. You might inherit class X from this library and class Y from this library. Sometimes they do have the same data member. And there is no good way to avoid this. The only ways that you can avoid this problem is to call a function or to refer to a function with the full scope. So in this case, you have staff with mname and student with mname. So inside the class tutor, you cannot call mname because that is ambiguous. When you call mname in tutor, the compiler doesn't know which mname. But you can avert this problem by giving it a full qualified name. So instead of .mname, you can call staff. This is no longer ambiguous. Yeah, so there is no good way to avoid this problem, but there is workaround. This is a workaround. This is actually we probably run out of time. Yeah, this lecture is supposed to be taught in 2 days. Anyway, I guess we can stop here. And we'll talk about this later.